As we completed about the discussion about construction working and the expressions to calculate GCV and NCV, next we shall switch over to the numerical problem on bomb calorimeter. So here I have written one of the problem, okay. So by using this data, how we need to calculate the GCV and NCV. That is what we need to do here, okay. If you just look over this, have a look towards this numerical problem. What he is telling, on burning 0.76 into 10 raised minus 3 kilogram of a solid fuel in a bomb calorimeter. So the temperature of 2.5 kg of water is increased from 25 degrees centigrade to 28 degrees centigrade. And the water equivalent of calorimeter and latent heat of steam are 0.486 kilogram and 2457 kilojoules per kg respectively. Calculate GCV and NCV of the fuel. Given specific heat as 4.187 kilojoules per kg per degree centigrade, and he has also given the percentage of hydrogen which is present in the fuel is 2.5. So this is the actual numerical problem where you people need to know what are the given data. So my sincere advice for you people is to go through the numerical problem twice before going to solve it. First you need to analyze what he has given and what you need to calculate. And moreover, the units, especially the mass of the fuel, mass of the water and water equivalents and specific heat and latent heat of steam. So what will be the mass they have provided, and GCV and NCV, it is always expressed in kilojoules per kg. Okay, so kilograms, we are expressing that in terms of kilojoules per kilogram, and hence the mass of water and water equivalent mass and the mass of the fuel, everything should be in terms of kilograms itself. So that is the very important thing what you need to look over in the given numerical problem. It seems to be very easy, but once you go for calculating, somewhere you may go wrong. So that's why I am very specifying about these things. You should be very careful about the units. Okay, so let us see what is the given data in this particular numerical problem. Okay, so he is telling on burning 0.76 into 10 raised minus 3 kilogram of solid fuel. So it means he has given the mass of the fuel. So mass of the fuel, we know it is expressed in small m. So mass of the fuel is nothing but 0.76 into 10 raised minus 3 kilogram. This is the given data. First you need to write down all these given data, then you have to apply it for the expressions to calculate GCV and NCV. Next, what he has given, after burning the temperature of 2.5 kg of water. So the temperature of 2.5 kg of water means he has given the weight of the water which is taken inside the bomb calorimeter, which is expressed as capital W, that is weight of the water is 2.5 kg. 2.5 kg. Next, he is increased the 2.5 kg of water, temperature is increased from 25 degrees centigrade to 28 degrees centigrade. So there is a rise in temperature during the combustion process. So initial temperature will be 25 degree and final temperature will be 28 degree. So the next given data here is T1 degree centigrade, which is 25 degree centigrade, and T2 it is 28 degree centigrade. 28 degree centigrade. So he has provided with T1 and he has provided with T2. So if you just subtract T2 by T1, you will be knowing what's the rise in the temperature, because 28 minus 25 degree, it is nothing but 3 degrees Celsius. That is the temperature which has been raised during the combustion of the 0.76 into 10 raised minus 3 kg of the fuel inside the bomb calorimeter. Okay, so next, what is the next data he has given? We came to know about the weight of the fuel, that is mass, weight of the water, and the rise in the temperature, and next he is telling the water equivalent of calorimeter and latent heat of steam are 0.486 kilogram and 2457 kilojoules per kg. So he has been given small w, that is water equivalent mass, okay, so that is 0.486 kilogram, and he has also given latent heat of steam, that is 2457 kilojoules per kg respectively. Next, calculate GCV and NCV of the fuel, and he has also given specific heat, that is 4.187 kilojoules per kg per degree centigrade, and the percentage of hydrogen as 2.5. So here the next what he has provided is, he has provided with specific heat, that is 4.187 kilojoules per kg per degree centigrade, and he has also provided the percentage of hydrogen, it is nothing but 2.5. So these are all the given data which I have written at a side. So this is how you need to go during the calculation part. Okay, all of a sudden you are not supposed to write the equation and calculate GCV and NCV, because somewhere you may go wrong here. So first write down whatever the given data. What is M, what is W, what is T1, what is T2, what is small w. Next, what is the specific heat he has given, what is the latent heat of steam he has given, and whether he has provided with the percentage of hydrogen or what. Okay, so by using these data, next we need to calculate GCV, that is gross calorific value. So what do you mean by this gross calorific value? As I have explained, to calculate that we are considering capital W plus small w into T2 minus T1 into specific heat divided by M, that is mass of fuel, that is in terms of kilojoules per kg. So this is the expression which we use to calculate GCV. Next, if you just write down all the terms whatever he has given from the data, so what will be the next step? GCV is equal to, what is W? It is 2.5. There is no need to convert any units here, because he has directly given everything in terms of kilograms, because we are expressing the final GCV in terms of kilojoules per kg. In case if we had given in terms of grams, then you need to convert that into kilograms. Is it clear? For example, if he has given the mass of the fuel as 0.76 grams, then you need to convert that into kilogram. Hey, how you will convert that into kilogram? By just multiplying it by 10 to the power of minus 3. Is it clear? So here 2.5 plus what is the water equivalent of calorimeter? 0.486. Okay, so that is also in terms of kg, into what is T2? T2 is 28 degrees centigrade and T1 is 25 degrees centigrade. So 28 minus 25 into, he has provided with specific heat in the given data, that is 4.187, okay, divided by what is the mass he has provided here. So mass is 0.76 into 10 to the power of minus 3. 10 to the power of minus 3. So this is how you can put all the values in the expression to calculate GCV. Okay, so when you simplify this and when you calculate, the final answer for GCV will be 49,351 kilojoules per kg. Kilojoules per kg. If you simplify by using a calculator, you will be end up with this answer as GCV. Okay, so is it clear? Hopefully you people have understood. Once again I repeat, just note down the given data from the numerical problem and then check whether the units are proper. If you want any conversions from grams to kilograms, you have to convert that. Okay, and here GCV equation has to be written. GCV is nothing but W plus W into rise in the temperature into specific heat divided by mass. If you just put those values in the equation, the final answer after simplification is 49,351 kilojoules per kg. Okay, so next we shall discuss how to calculate NCV, because here he has also told us to calculate both GCV as well as NCV. So how to calculate NCV? We know the numerical mathematical expression to calculate NCV. NCV is nothing but GCV minus 0.09 into percentage of hydrogen into latent heat of steam, kilojoules per kg, 0 kilojoules per kg. So now if you just put the values here for the calculating NCV, so we know what is the value for GCV. GCV, it is nothing but 49,351. So write down that 49,351 minus 0.09 into what is the percentage of hydrogen he has provided. So percentage of hydrogen is 2.5. So here it is 2.5 into what is L? L is nothing but the specific latent heat of steam. So he has provided latent heat of steam as 2,457 kilojoules per kg. Kilojoules per kg. If you simplify this, you will end up with 48,798 kilojoules per kg as NCV. If you just observe the value of GCV and NCV, GCV is always greater than NCV. As I told, gross is nothing but the high calorific value, net is nothing but the low calorific value. What's the reason? You should know this reason. Why always NCV will be lesser than GCV? Because in GCV we are considering the amount of heat liberated during the combustion process plus the amount of heat released during the condensation of the byproducts. Whereas in case of NCV, we are considering only the amount of heat released during the combustion process, whereas the amount of heat during the condensation of the byproducts has been subtracted. Means we are just removing that. Okay, so that is why we are considering 0.09 into percentage of hydrogen into latent heat of steam. If you just subtract that from GCV, then you will be getting what is the net calorific value. Is it clear? This is how you need to solve by considering the given data and come out with GCV value and NCV value. Okay, hopefully this numerical problem is clear for you people. Okay, we shall go to the next numerical problem under calorific value. So here I have written one more numerical problem here. What he is stating here, calculate the gross calorific value of a given sample of coal from the following data. So he has told only to calculate the gross calorific value from the following data. So what is the data he has given? Just have a look here. He has given the mass of the coal as 6 grams, mass of water plus water equivalent of calorimeter, both W and small w. Altogether he has given it as 2200 gram. And he has given a specific heat of water 4.187 kilojoules per kg per degree centigrade, and rise in temperature is 6.52 degrees centigrade, because he has not given the initial temperature and the final temperature. Instead of that, he has just given the rise in temperature, which is nothing but T2 minus T1. Okay, you are not supposed to get confused. Okay, rise in temperature means it is already subtracted, means the final temperature is being subtracted with the initial temperature, and what is the difference we have got, that what we call it as rise in temperature has been directly given in this numerical problem. Okay, so before going for the calculation part, as I told, in the numerical problem, if you want to calculate GCV and NCV, the very important thing what you should know here is about the units, because we are expressing the GCV and NCV in terms of kilojoules per kg, okay, because he has given the specific heat of water in terms of kilojoules per kg per degree centigrade. The final answer will be expressed in terms of kilojoules per kg. But in this numerical problem, he has given the mass of the sample, that is coal sample, in terms of grams, and the mass of the water and water equivalent of calorimeter in terms of grams, and specific heat in terms of kilograms, and rise in temperature in terms of degrees Celsius. So what are the things that has to be changed here, or that has to be converted? That is very important. Okay, so first we need to convert this grams, that is the mass of the coal which is given in terms of grams, into kilograms. So how to convert this grams into kilograms? We know that when you multiply this gram by 10 raised minus 3, it leads to kilograms. 10 raised minus 3, it leads to kilogram. Okay, so here first we need to know about the mass of the fuel. Mass of the fuel, which is given as 6 grams. So 6 into 10 raised minus 3 kg. We are converting that grams into kilograms. So how we are converting this? By multiplying that 6 into 10 raised minus 3. So that gives you in kilograms. Okay. Next, we have to convert the mass of water, that is capital W plus small w, okay, both water equivalent of calorimeter. He has given that as 2200 grams. So from grams to kilograms means 2200 into 10 raised minus 3 kilogram. 10 raised minus 3 kilogram. Okay, so specific heat, there is no change because he has directly given 4.187 kilojoules per kg per degree centigrade, and temperature also in terms of degree Celsius. So there is no change in those two units. The only change that has taken place here is about the mass of the fuel and mass of the water and water equivalent. Hopefully this is clear for you people. Okay, so after this, the next important thing is to calculate GCV, because here in this numerical problem he has not given the percentage of hydrogen and he has not given the latent heat of steam. So it's very clear that you people need to calculate only GCV and you are not bothered about NCV. Okay, so what is the expression to calculate GCV? Okay, so first we shall write down the expression to calculate GCV. GCV is equal to W plus small w into T2 minus T1 into specific heat S divided by M is the mass of the fuel. M is the mass of the fuel. Just write down the given data into that expression. We know what is W plus W, that is water and water equivalent of calorimeter. It has been converted into grams to kilograms. So 2200 into 10 raised minus 3 kg into T2 minus T1 degree centigrade, that is the rise in temperature. So in this numerical problem, he has directly given what is the rise in temperature. He is telling it as 6.52 degree centigrade. Okay, that into what is the specific heat he has given? He has given it as 4.187. So let us write it as 4.187 divided by what is the mass of the fuel given? Mass is 6 into 10 raised minus 3 kg. 6 into 10 raised minus 3 kg. Okay, so after writing all this given data into the expression, if you just simplify this, you will be end up with the answer that is 10,009.72 kilojoules per kg as the final gross calorific value after simplification. Once again, I am telling here, in this case, in this numerical problem, since he has given specific heat in terms of kilojoules per kg, you have to convert the mass which is provided in terms of grams into kilograms. If you forget to convert that grams into kilograms, and if you just directly take 6 as the final value to calculate gross calorific value, then the overall problem will end up with error. Okay, is it clear? So whatever the weight that has been provided, if you need to just see what is the unit he has provided for specific heat, he is clearly telling that it is kilojoules per kg. Since he is given specific heat in terms of kilojoules per kg, you have to convert the mass of the fuel and the mass of the water equivalent into kilograms. So how to convert means just multiply that into 10 raised minus 3, that will gives you in terms of kg. So you should be very specific about these conversions. Hopefully it's very clear. So after the conversion, then put it into the formula and come out with the results. Okay. So in this one more thing what I need to tell is there is no question of calculating NCV. Why means if you just see the numerical problem, he has never given the percentage of hydrogen and he has never given the latent heat of steam. Okay, sometimes he may give the percentage of hydrogen and he may forget to give the latent heat of steam. So at that time you have to assume the value for latent heat of steam because it's a constant. Okay, and that has to be put in the formula and you have to calculate NCV also. Okay, in case in the numerical problem he stress only to calculate GCV, then no need to calculate NCV. In case if he just tell you to calculate the calorific value by given data, okay, in the given data if he has provided with everything, W plus small w, mass of the fuel and specific heat, latent heat along with the percentage of hydrogen and rise in the temperature, then it's very clear that you need to calculate GCV as well as NCV. Is it clear? So we shall go for the next numerical problem under a bomb calorimeter. So the given data I have written on the board. This is the one more type of problem where you can expect such problems in examination also. If you just go through the data, what he has provided here. See, he tells that mass of a coal sample of 0.75 grams which contains carbon 90%, hydrogen 6%, and ash as 4% was subjected to combustion in a bomb calorimeter. So what he is telling, a known mass of fuel, that is coal sample of 0.75 gram is taken inside a bomb calorimeter, and in this 0.75 gram it contains carbon 90%, hydrogen 6% and ashes as 4%. Okay, so these are the overall percentage of chemicals, that is hydrogen and carbon along with ash, which is present in that given 0.75 gram of coal sample, which is subjected for combustion in a bomb calorimeter. And during combustion process, what he does, mass of water taken inside the bomb calorimeter is 300 gram and water equivalent of calorimeter is 750 grams. And rise in the temperature was found to be 3.2 degrees centigrade, and he clearly tells us to calculate GCV and NCV by giving the specific data, that is specific heat of water as 4.187 kilojoules per kg per degree centigrade and latent heat of steam as 2454 kilojoules per kg per degree centigrade. Okay, so this is the given data. If you just observe this numerical problem, you may get confused why he has provided the percentage of carbon and percentage of ash which is not required here. Where we need to consider this. This will be the little bit confusing state for students to attempt these particular questions. See, whatever data he might be given, you are not supposed to worry about the extra data he has provided here. You need to take whatever the data that is required to calculate GCV and NCV, because some may have questions or where we need to consider the percentage of carbon. See, we are not considering the percentage of carbon or percentage of ash which is present in that given coal sample, because we need only the percentage of hydrogen to calculate NCV, the net calorific value, because the byproduct water which will be in the steam form is converted into liquid state, that is, it has been condensed back. So that's why we want only the percentage of hydrogen present in that particular fuel to remove that the latent heat of steam from that of GCV. So that's why in such type of questions, Okay, you need not get bothered about the percentage of carbon and percentage of ash, where we are not considering these two percentage to calculate GCV and NCV. Is it clear? Yes, fine. So now we need to note down the data what he has given. The very first thing, as I told, before solving any numerical problem, it might be in any of the modules, the very first thing what you people should do is to note down the data first. If you note down the data properly, then you will be knowing what he has given, what we need to convert, whether it is in terms of grams or kilograms, whether we need to convert that in terms of calories to kilojoules. Okay, everything has to be known properly. So that's why my sincere advice for you people is to note down the given data properly. So first we need to know M. M is nothing but the mass of the fuel. He has given that in terms of 0.75 grams. So in terms of grams means the specific heat provided is in terms of kilojoules per kg. Hence you have to convert this mass of the fuel from 0.75 grams into kilograms. So 0.75 into 10 to the power of minus 3 kilogram. Next, what W, that is capital W, that is nothing but the weight of the water taken inside the calorimeter. He has provided it as 300. Okay, and he has given the water equivalent of calorimeter as 750 grams. So overall we shall consider both 300 plus 750, which is nothing but 1050. That is in terms of grams. You have to convert that in terms of kilograms. Okay, so W plus W. Overall we are considering 300 plus 750, that is 1050, that in terms of grams is converted into terms of kilograms into 10 raised minus 3. Next, what he has given? He has given rise in temperature, that is T2 minus T1 degree. Directly he has provided as 3.2 degree centigrade. So 3.2 degree centigrade is the rise in the temperature, T2 minus T1, and he has given the specific heat of water as 4.187 kilojoules per kg and latent heat of steam as 2454 kilojoules per kg per degree centigrade. Okay, and the very important thing here is to note down the percentage of hydrogen. So here we require only the percentage of hydrogen to calculate NCV, and hence you need to consider only hydrogen percentage and least bothered about carbon and ash. Is it clear? So by using these data, we need to calculate GCV. So GCV is nothing but W plus small w into T2 minus T1 into specific heat divided by mass. So when you just put these values here, what happens? 1050 into 10 raised minus 3 kilogram into rise in temperature is 3.2 degrees centigrade, okay, into specific heat is 4.187 divided by what's the mass? Mass he has given as 0.75 into 10 raised minus 3 kilogram. So if you just simplify this, so the final answer will be 18,757.76 kilojoules per kg. So this will be the GCV. This will be the GCV. Hopefully it's clear for you people. Next we need to calculate NCV. Okay, what is the formula to calculate NCV? So NCV is nothing but GCV minus 0.09 into percentage of hydrogen into specific latent heat of steam. Sorry, it's latent heat of steam. So we know what is GCV, 18,757.76, okay, minus 0.09 into what's the percentage of hydrogen he has provided? He has provided as 6%. So note down 6 into, he has given latent heat of steam as 2454 kilojoules. Okay, so if you just simplify this, next NCV, it will be, the final answer will be 17,432.6 kilojoules per kg, 6 kilojoules per kg. So this is NCV. This is NCV. Okay, so now by using this data we have calculated GCV as well as NCV. Okay. So these are the next numerical problems which I have written on the board, okay, which has been asked in examinations, okay, and these two numerical problems are the homeworks for you people to work out in your home and come out with the results. I have not given the answers also here because you need to work out and come out with the answers, okay. So in this first numerical problem I will just give the hint how to calculate this, and it's very simple to the previous problem what we have done here. Okay, so mass of the coal sample of 1.2 kg contains 4% of hydrogen in it and was subjected to combustion in a bomb calorimeter. The mass of the water taken was 280 gram and water equivalent of calorimeter was 820 gram. The rise in temperature was found to be 5.2 degrees centigrade. Calculate GCV and NCV by given data, that is specific heat of water as 4.187 kilojoules per kg per degree centigrade and the latent heat of steam as 2454 kilojoules per kg. So this is one of the numerical problem which has been given to you to work out by yourself. And if you just look out this data, you can see the mass of the fuel sample, it is directly given in terms of kilograms, okay, kg. So there is no need to convert that in terms of grams because the specific heat is already in kilojoules per kg. So the only thing that has to be converted here is the mass of the water and water equivalent, which is already given in terms of 280 grams and 820 grams. So here W plus W, that is 280 plus 820 into 10 raised minus 3 is how to convert the given mass of the water and water equivalent from grams to kilograms. So the remaining data are as such. He has directly given the rise in temperature, that is T2 minus T1 degree centigrade, that is 5.2, which can be directly taken for calculation part, okay. And to calculate the NCV, here he has given only the percentage of hydrogen, that is 4, which has to be taken as 0.09 into 4 into latent heat of steam. Okay, so this is one such numerical problem. Coming to the second one here, this is very important. Okay, if you go through this numerical problem, you can just see on burning 1.15 gram of a coal sample in a bomb calorimeter, the temperature of 3.5 kg of water in the calorimeter increased from 26.5 degrees centigrade to 29.7 degrees centigrade, and water equivalent of calorimeter is 325 gram. And specific heat of water is 4.187 kilojoules per kg per degree centigrade, and latent heat of steam, which I have highlighted, it is in terms of 587 calorie per gram, and he tells to calculate you NCV and GCV by considering the percentage of hydrogen as 4. So in this numerical problem, which is slightly different from the previous problems which we have done, because the latent heat of steam he has provided in terms of calorie per gram, but we are expressing the GCV in terms of kilojoules per kg. So here you should be very careful to convert the latent heat of steam from grams to kilocalories per gram to kilojoules per kg. You need to multiply this latent heat of steam, okay, that is 587 calorie per gram, okay, into specific heat, that is 4.187, okay, into specific heat, that will gives you in terms of kilojoules per kg. So always remember this, in case latent heat of steam is provided in calorie per gram, then you have to multiply it by specific heat to convert that calorie per gram to kilojoules per kg. This is very important, okay, that's why I have highlighted this, okay. So here in the remaining thing, he has provided the mass of the fuel in terms of grams, you have to convert that into terms of kg, and here he has provided the water equivalent and the mass of water in terms of grams here, that is 325, and he has provided the water in terms of kg, the mass of the water in terms of kg. So there is no need to convert this 3.5 into 10 raised minus 3 because it's in kg, whereas you need to take only 325 gram, which is the water equivalent mass. Okay, so that needs to be converted from grams to kilograms. Okay, so you should be very careful about these conversions. Okay, hopefully you people have understood, and you need to work out these two numerical problems, so it will be very easy to know how to crack this particular numerical problems and come out with GCV and NCV value. If this